So I welcome you all to this playlist on introduction to special relativity. So in this playlist, what I hope to do is to introduce you to the basics of special relativity. So in the first video of this playlist, we are going to talk about the fundamentals of Galilean transformations. So when we consider Galilean transformations as a basic case, there are two observers. Both are inertial observers and they are named as S and S prime. So with respect to S frame is moving, or the S prime observer is moving to the right direction with a velocity v. So when that person moves to the right direction, their x and x prime axis are coinciding, and there's no motion in the other directions like y and z. So if the S prime observer observes an event which is happening in the location E1, so that's the event that the S prime observer is observing, so that the location of that event can be written in the S prime frame as x dash. So before talking about the transformation, I'll tell what an event is. An event is something happening in a frame to which there's a space coordinate and a time coordinate. So in this case, E1 is the event that the S prime observer observes. So in his frame, the space location or the space coordinate is x prime. So the other coordinates for this event can be written as y prime and c prime, which are the same for the S observer as well, but x prime is not the coordinate that is registered by the S observer. To convert that into S observer's coordinates, we need to add x prime plus another amount vt, because there's a relative motion in this direction. So x is equal to x prime plus vt. So that's how we write down the event location or the space coordinate in S observer's frame. So when we consider all these transformations together, we can write these transformations as x prime equals x minus vt and y prime equals y and z prime equals z. So this is what we call the Galilean transformations, and here you may see that I have written this in the other way. So this is the inverse transformation of this transformation that I have written here. So we will talk about these transformations and what is a transformation and what is an inverse transformation in detail in the upcoming videos. And another important thing is that in Newtonian mechanics, the time is an invariant. That means the time does not change because of the relative motion between observers. So in time in S prime observer's frame is same as the time in S observer's frame. So that means t prime equals t. So those are the basic things that I need to talk about in this video on Galilean transformations. In the later videos, we'll talk more about the Galilean transformations, as well as we will reach the Lorentz transformations, which are very important and key and plays a key role in special relativity. So thank you.